Hello and welcome back to Tech Days Online 2017. I'm Andrew Fryer and we're going to be talking about documents. And in fact, if you look at my tie really closely, you can see that man has been playing with documents for thousands of years. In Egyptian, in Greek, this is the Rosetta Stone. However, rolling forward to 2017, the hot topic and the way that documents are often stored now are in JSON format. And frankly, I'm a bit new to JSON, so I've got a very good friend of mine of 10 years now, Alan Mitchell, to talk to us about something called DocumentDB.
Yeah, that's right. Okay, so during this session, hopefully I'll explain to you more about what DocumentDB is, what its use cases are, some of the wins that you can have with it, and I'll also include some of the things that the team are doing, and maybe they're not as well highlighted. And I'll also call out some resources for you at the end, so you can go do your own study.
Sounds like a plan, because you're out there in the real world implementing this stuff.
Yeah, that's right, that's right. So one of the things that I wanted to highlight was I think this is one of those services in Azure that maybe isn't as prominent as something like Azure SQL DB or Azure SQL Data Warehouse, those types of things, but it's a really, really useful service.
Okay, well, take it away, sir.
Okay, so this is me. I'll not spend too much time, but this is me. So I'm a data to platform MVP, used to be SQL Server, but I do so much more now than just SQL Server. So like I said, what I want to do during this session really is describe what is DocumentDB, some of the use cases that you can have, going big. So going big has become interesting now in DocumentDB. It used to be, you could still go big, but it was a management nightmare, right?
Right.
So now, there's a whole load of things that we can do that make it so much easier to go big. You want 4 terabytes worth of DocDB storage? All good, right?
Wow.
And some of the wins as well. So those are the things that I was saying that have been released that really have gone in under the covers. So DocumentDB, it's a platform service, first of all. Means you don't manage anything, right? So you don't have to worry about storage, you don't have to worry about compute, you don't have to worry about uptime, downtime, you don't have to worry about backups. DocumentDB has all of that covered for you.
Okay.
It's a NoSQL document database, so schema-free, right? So you don't need to write it with a schema. So when you write these documents, which as you've said are JSON, JavaScript object notation, you can do it with an arbitrary shape.
Right.
Right? So you can have deeply nested, you can have relatively flat, and you can then use an easy-to-use SQL syntax. So I think what the team did when they were designing DocDB is they said, what language are people most comfortable with? What language would people want to be able to query? And a SQL-like syntax is that language. So what we'll do is I'll show you on the emulator exactly that. And the emulator is another thing which kind of snuck out there and without much fanfare.
Yeah.
It's you and I do an awful lot of traveling, right? So we go to conferences, we go around the world, we're on trains, on planes. One of the things that certainly I wanted from relatively early days was some way of doing DocDB, but doing it on my laptop whilst traveling to wherever I was going.
Sure.
And that now has been released in the form of an emulator.
Great.
So I'll show you that as well.
Super duper. Because I'm intrigued, you know, we obviously both started out with our common love of that SQL Server thing, and this is a very different world we're in now.
It is, it is. So I think Microsoft's data platform landscape has changed incredibly. So there's a whole raft of data services, and Amy covered that up at the first session this morning. But yeah, it's changed massively. It's changed massively. SQL Server is still an incredibly good product, but there are other products out there from Microsoft that do different things and may be a better fit in some circumstances.
Indeed.
So what are the typical use cases? So if you look them up, they're logging. So people do an awful lot of logging in DocumentDB.
Yeah, I think we use it at Skype to
Yep.
log all the calls. Yeah.
Correct. And telemetry. So you use telemetry on your Xbox games.
And Toyota connected cars, I think,
Yep.
is another example there. Yeah.
Yep. So with these first two, with this scale-out story that I was talking about earlier, that becomes a real possibility. Because before, when I tried before this whole scale-out thing, I used to get errors that said, no, you can't do that. You're trying to insert into me too quickly, back off,
right.
back off.
Okay.
Right, but now, and I'll show you later on, is now you're able to push into DocDB much, much quicker, and it scales beautifully.
Fantastic.
But where I also see it is people who want flexible storage. So rows and columns are fine. A lot of people don't have rows and columns. So a lot of people have to go into something like Entity Framework to take their objects that they're using in their applications and then push them into a relational model. And sometimes that doesn't work, right? I've also seen where people pass around JSON around their applications through service bus and things like that. Then they put it into a relational store. Then they take it out of the relational store and push it back into JSON.
And you do work with IoT, and that produces a lot of JSON as well, I guess.
Correct. So coming in and out of JSON into a relational model takes a lot of CPU cycles. With DocumentDB, you don't have to do that, right? You just write into JSON, read out as JSON. Yeah, so flexible storage is one of the big winners here.
Yeah.
So we've got a customer, right, who has this, who do experiments. They do experiments, and their data is of varying shapes. They have some attributes which are common across all of their experiments. And what they want to do is they want to be able to search over those experiments, retrieve those experiments, and do it quickly and at scale. DocDB and Azure Search are fantastic for doing that.
Right.
And it's a pattern we've used a lot. Search and DocDB, absolutely brilliant. So these guys are passing around these experiments in JSON. We can write them into DocumentDB, and we can retrieve them very easily. So this is the model that we've implemented for them.
Okay.
So they've got a whole load of Azure functions, right? And the Azure functions take a feed and then they push out, right? So they do some compute in the middle, and they push out. They push out into Azure Search and DocumentDB at the same time. Into Azure Search, what we do is we put into Azure Search a certain set of attributes, which allows us to do things like highlighting, suggesters. It allows us to parse the text in a full text way. Right? So it allows us to do some really funky search over these attributes. The result of that search is, you might say, I'm looking for an experiment where this ingredient was used, right? And the ingredient could be included in the remarks. It could be included in wherever you want, right?
Anywhere in that tree structure.
Anywhere in that tree structure, right? So in Azure Search, what we do is we find that, and we return a list of IDs. Then what we do is we go to DocumentDB and say, hey, DocumentDB, I need these IDs. Can you return to me the fuller state? And it says, here you go. And we can do that two-stage thing less than half a second.
What, when you submit?
Yep.
Wow.
Yeah, so they ask for it, get the IDs, go back to DocDB, and return the documents less than half a second.
And how many documents are we talking about storing here?
So at the moment, we're only talking 1 million.
Okay, so not a huge.
So it's not a huge amount, but it will go bigger, right?
And it's not going to slow down when you do that?
No, because if it does, you know what, we'll just scale it out, scale it out, scale it out.
Sure.
Yeah, okay. So, we've designed it with scale in mind to start with. So scaling it out is absolutely no problem whatsoever.
And as the experiments change and so on, each different experiment's going to have a slightly different structure within the overall schema. You haven't had to worry about aching them over column design, indexing, normalization and all of that stuff. We all got grey hairs
Yep.
learning all those years ago. Fantastic.
So one of the beauties of DocDB is that by default, they index everything.
Oh, yeah, okay.
Yeah, so you don't have to worry about how are people going to query my documents. They index everything, right? So by default, you get over textual data, you get a hash index. So you can do your nice indexes over text. But over your numeric data, you get a range index.
All right.
So you can do show me all experiments where the value of this was greater than X.
Yeah.
Right.
Okay.
Brilliant. Then all we do is we just put a little web app over the top. Put a web app over the top of Azure Search, so we can type in the box and it says, I think you're looking for this, type yes, and it brings it back. And like I said, half a second response time.
And all of that is, I can see, is PaaS based. So we're not running dependent on any VMs. This is all going to completely scale according to demand. More functions, more web front ends if they need it. Scale out your document DB, and search scales by itself pretty much anyway.
Yeah. So search is massively scalable. Azure DocDB is massively scalable. Web apps you can scale as well. So all of these things, you're right. PaaS is for us where we start with Azure, and we don't necessarily want to go to IaaS, which is infrastructure as a service, unless there's some reason why we can't do it in the platform.
Yeah.
Because we don't want to manage tin. Yeah. So we want you guys to manage tin, right?
We're happy to do that for you, Alan.
Exactly. So it'll go to Azure Search, but then it goes to DocDB and it returns the actual documents.
Yep.
So remember what I was saying earlier on about scaling. So in the old days, it was when DocDB first came out, you had this thing of a single collection. A collection could only be 10 gigs in size, right? Fine. And it had a certain amount of throughput, right? So a certain amount of IU resource units, right? So that was fine, but do you know what? We used to go to customers. We used to go to quite a few customers, and I don't know what it is about the size of 3 terabytes, but people wanted 3 terabytes. And you could do that. You could do that, but you do the maths, right?
I'm just doing the maths now. 300?
10 gig collections, doing that, and then you have to manage in your application, I've got to go to this collection, I've got to go to this one, I've got to go to this one, I've got to go to this.
You've got to know which collection your document's in as well, so that's really hard.
Yeah, well, so it becomes a management nightmare, right?
Yeah, yeah.
So the DocDB team have released this thing called partitioned collections, which essentially takes all that away from you. Takes all that worrying away from you. The next 2 things on the slide are requestable throughput, requestable storage. So you come to them with I need this amount of throughput and I need this amount of storage. If it isn't available in the portal, you can raise a support ticket, and I'll show you how to do that. That says, I would like 30 terabytes worth of storage, and I would like 50,000 IUs of throughput. Goes in, and there you go. You obviously pay for it.
Yeah.
But
Okay.
you get that.
And we're going to get to RUs as well, because I'm intrigued what an RU is.
So
Resource unit or something?
Yeah. So it's the ability to read 1 KB of data.
Ah, okay.
Yep.
So it's really quantified for us.
Yeah. So a partition collection, like I said, so you still can create that single partition. You can still have, if you've got a relatively small amount of data and you've got a relatively small amount of throughput needs, you can still do that, right? So you can still go provision your 10 gig collection, and you have 10,000 request units. You can do get, post. You can do all of the functionality that you want to do. But then you come through to partition collections. In the portal, the max you can go to is 250 gigs, and you can go up to 250,000 request units. Yeah. But like I said, if you want more, you can raise a support ticket, and you can get more.
So I guess that just stops people inadvertently running up a big bill. They didn't realise quite what they were doing. They've actually got to consciously think about that.
Yeah. So I guess Microsoft have put this thing in that says, okay, you know what? For most people, that's going to be good, right? But if you have those needs, then you've got to make a conscious decision to raise that ticket with us to provision that amount of throughput.
Yeah.
So this is taken from Books Online. And this is the difference between a partition collection and a single collection. So if you look, obviously in a single collection, we don't have a partition key. But in a partition collection, we need to know what the partitioning key is, right?
Yeah.
Because it needs to know in the document, how do I identify the partition key to know into which collection it's going to go.
So that, in the case we've just been talking about, be your experiment ID. So you've got a bucket of experiments over here, another one over there, and so on and so forth.
You could use experiment ID, or so it's important which key that you find. So ideally, you want to have collections which are evenly distributed.
Of course.
So it could be.
So that's a bad idea then. What I
so
just
yours in your experiment IDs, you would have one document in each collection, right, which would be terrible.
Okay.
Right.
Sorry about that.
No.
Sorry about that.
So maybe if you do experiments with different regions, maybe you do it by region, maybe you do it by time, maybe you do it by person doing the experiment.
But if you're doing it by time, for example, and then you say we're in February 2017 at the moment, that partition for February 2017 is getting hammered with all the updates and what have you. Probably also for queries, people are probably going to want to look at the most recent experiments, and the other ones are going to get less stressed. So that may not be a brilliant idea either.
Correct. So what I'm saying is that when you choose your partition, choose it carefully.
Yeah. Okay.
Yeah, understand that you don't particularly want a hotspot.
Yeah.
You ideally would like it to be doing this. When you're inserting data, you would ideally be liking it to do this, because then you take advantage of all the throughput that you've got, right? And all the storage, and it's all good. And like you said, when you query, it's going to go to the right collection and be able to retrieve that data.
Rightio.
So, storage, single partition collection, which is 10 gigs, all good. But the other one is a partition collection, and you can have unlimited, right? Same with throughputs, 10,000 in the single and unlimited in the partition.
Wow.
So API versions, so what the Document DB team do and the Azure Search team do is they release different versions of the API. So when they release a new version of the API, you're on the older version, so you haven't taken up the new stuff, your stuff doesn't break.
Yeah.
Right? If you want the new stuff, you've got to
use
go
the new
to the
version.
new API.
Understand.
And so partition collections were introduced in the 16th of December 2015 API release. Yeah. So that's some of the things, some of the different differentiators between the collections. So this is some code now. So it's a bit of C#. We're going to create a collection. I thought I'd put it onto a slide rather than live demoing. So if we have a little look.
Oh yeah, thanks for zooming that in. I can just about read it now.
Yep. So there you go. So you'll see that we create a document clients. And then you'll see my collection.partitionkey.paths.add/company.
Yep.
That's the part where you say, that is my partition key, right?
Yep.
So for each company, I'm going to have a different partition, right? So we've made the choice there. And down the bottom, we've got new offer throughputs. So
Yep.
So this is how much power do you want? Yeah. So relatively easy. That's a couple of lines more in the setup than you would have done in the old days when you only had a single collection. But it's not arduous. It's not.
No.
There's not reams and reams of code.
And there's all sorts of ways of getting it. You've used C#, but people could use CLI maybe.
Yep.
Because I tend to think of this as being NoSQL as being open source. And we'll do some more on that tomorrow, but that's how we do that.
Yep. So this is C#, but yeah, there's other ways of doing it. Right?
Cool.
Right. So then what you do is you query a partition collection, right? So we've got this partition collection. So what we're doing here is we're saying, I want to go to XMS001FE24C is my ID.
Yep.
In collection called col. And the partition key is XMS0001.
Gotcha.
Right? Again, not too much code.
So you just have to put that extra partition key in where normally in a document DB query you wouldn't have to worry.
Yeah, you wouldn't have to worry because we're not going, there's no choice, right?
Yeah, gotcha.
What we could also do is we could use this method. So we don't need to specify the partition key because our query here specifically says device ID, which is our partition key, is equal to XMS0001.
Yep.
Yeah? So document DB is smart enough to say, haha, I know that that's our partition key, therefore I can route it accordingly.
Right.
Yeah? So this would be where you don't query by the ID, which was the previous version.
Yep.
This is where the metric type is temperature and the device ID is XMS001.
Yep.
So this might be for an IoT scenario where we've got lots of devices streaming data in or pushing data in from whatever machinery on your shop floor. Yeah, so maybe we partition it up by the device IDs.
Yeah, so we might have a floor or an office block or a hotel room or whatever it is,
or whatever it is. So it could be that you have smart meters measuring heat, I don't know, right? And each of those is tagged with a building or a room or whatever. You push it in, you could have your device ID is equal to building 1, room 10. Yeah.
And if you want to scan across multiple collections, you have to write a query here. Say we want to get all the rooms that are hotter than 25 degrees.
Aha.
Aha. I feel as an aha. It's like I've read your slides, isn't it? Thank you.
I forget what that's called. It's a great question is when I've got the answer on the next slide or something.
Yeah, I'll give you that $5 after the show.
Yeah, thank you. So you'll see that yes, if you want to query cross partition, you just do enable cross partition query is equal to true.
Yeah.
So this would be temperatures where the metric value is greater than 0 and go across all my devices. Right?
It's all the freezers that are broken potentially.
All the freezers that are broken or all of our room sensors, that type of thing, right? So yeah, you can go across all of your
fantastic
different partitions.
So I can understand this. This is good.
Yeah. So you've got your collection. You've been using DocDB for two years-ish. And you've got your collection, which is a single partition. What about if you want to push it into a partitioned collection? So easiest way and the recommended way is you export it to JSON and import it back in. And the document DB have got a tool that will allow you to just do that, right? So it's kind of like AZ copy type of thing. Yeah. So you can specify. There's a number of things that you can specify. So you can come from Mongo. You can export into DocDB. You can export to JSON, import from JSON. Yeah. So there's different ways of us getting our data that was previously held in a single collection and moving it into a partitioned collection.
Great. Okay.
Yeah. So there is that migration story.
Cool.
Right, so I pinched this. So we spoke earlier. So this is one slide that we did speak about earlier. So I pinched this slide from a blog post by Rimmer this morning about winning over the Mongo community.
Mm.
If you're a document database user and you've been using one for a while, chances are that the thing that you're going to have been using is Mongo.
Right.
Right? So Mongo. So what the Azure Document DB team did, they said, well, look, Mongo's out there, right? We can't stop that. But how about we make it easier for people to use Document DB and them having a nice, easy story about taking their applications written for Mongo and pushing storage into DocDB.
Yeah, because I mean, I suppose in our sort of heritage world, you know, you've got maybe some PLSQL sitting around, and you've got to convert it to T-SQL, and that can be hard, right? So how have they got round that for this?
So they've created this Mongo API layer.
Oh, right, okay.
Yeah. So your applications can address Document DB as though it was a MongoDB backend.
Okay.
And have Document DB at the back.
So you just need to change connection strings?
So you just change your connections. It's just where you're pointing.
Wow. Impressive.
Yeah. So this is one of those things that I was saying at the top. This is one of those things that has been pushed out. Very few people even realise it's out there. But it is a big winner. So we've got a customer now who's currently using 3 terabytes of Mongo. Right?
That's on-premises, is that?
So that's on-premise currently. They want to go into Azure. They've invested an awful lot of time in Mongo. Right? This will be definitely something that we will be certainly doing spikes over to see, could we take their Mongo backend store, migrate it to Document DB? How do their applications talk to it? Because we would much prefer to get them onto Document DB with all the goodness, the scalability, the built-in backups, geo-replication.
Yeah, because for sure, I guess that the simple approach would be just say, well, let's just create a whole load of VMs and put Mongo in those, which you can do right now,
I mean,
right?
But you haven't that, right?
But you haven't solved their problem.
Correct. So you've taken them to Azure, and you're right. You could have this Mongo cluster in Azure, and all good. We can do that, right? And you will have these VMs, but you've got to manage the uptime of them now, right?
Yeah.
I would much rather I gave it to a Microsoft guy in a data center somewhere, and said, you know what? I'm just going to keep throwing my data at you. Your job is to keep it up. Yeah? Much better model.
Yeah.
So what I did do is I've hidden a slide, but I just want to unhide it.
No, that's good. Because obviously we can download these afterwards. So.
And here you go. So if you're in the portal.
Yeah, I'm going to have to get you to. Thank you.
So if you're in the portal and you search for Document DB, or you search for NoSQL, you're going to get 2 options, right? NoSQL with Document DB, or Database as a Service for MongoDB. Both are the same thing, right? So on the left, we've got the NoSQL Document DB. But what you'll do is you'll notice
that switch,
which says, I want to address you like your Mongo.
Yeah.
And you go through and you create it, and everything's exactly the same. What this one on the right here has done is you just go through and create everything just as you normally would.
Yeah.
Right? Because it's already got that box ticked at the back that says, Alan will talk to me as if I was Mongo.
And you have a choice, one or the other. You've
Correct.
got to be, which makes a certain amount of sense, I suppose.
Correct.
Okay, Alan, it's great stuff.
So that is a big win, and if there's anybody out there that's using Mongo and would like to go to a platform as their backend, Yeah? Brilliant.
Super duper.
Here's another one.
It's all over the place. Is that the UK I can see in it?
Might be. I don't know which one you're looking at.
Well, we're in England, aren't we? Oh, there's just a few there, aren't there? That looks like it. Some of those circles are definitely centred over the United Kingdom.
I would say so too. Right? So this is the other thing, right? Is you can create readable replicas of your Mongo, of your document DB in other regions of the world.
Right.
So this is very much, so for me this looks very much like availability groups in SQL Server.
Yeah.
But this is absolutely fantastic. God forbid that we have a region go down. Yeah? But if we did, the document DB team have got you covered. And just a word about the document DB team. So I've been lucky enough to spend, been invited into their offices, and we talk with them about stuff. They are a really approachable team. So if you've got a document DB query that you're not quite happy with, or you want to know something, reach out to them.
Yeah.
Right? Reach out to them. They're really, really friendly, and they will offer you an explanation, and they're a really good team.
Yeah, and do ping us after the show if you want to work on any of these kind of projects with this stuff and try out the MongoDB migration or something like that. We've got good contacts.
Yeah. So I mean, we've had people like Andrew Liu was over.
Yeah.
And we've got Andrew Ho coming over for SQL Bits.
It's got to be called Andrew to work on document DB.
Got to be called Andrew. Anyway. Yeah. I think there's other letters are available as well. But yeah, so you pay for it, but you can have. So in this one, you'll see that my right region is North Europe. I've not created any readable regions, right?
Yeah.
But I could do.
Sure.
I could go, maybe I've got people in Singapore that need to be able to read my data, right? And this is another one. I don't know that anybody's told anybody about this one.
No, there's lots of stuff on here, yeah.
So there is, yeah. So the important part of it is that on the left we've got document DB, right? So document DB is chugging along, it's doing its thing, right? You're updating, you're inserting, you're deleting, you're doing all of your stuff in DocDB. So what the DocDB team have now done is they've implemented what is essentially change data capture.
Right. Okay.
Right? So now you've got a change.
Yep.
So now this layer in the middle, which is Storm, Spark, Apache Hadoop, Azure Functions, etc., etc. Yeah, they're your real-time streaming stuff.
So you could do some. I mean, one of the things you often do is take a long string and then split it up for tagging and so on to make it easier to search, and you could do that in here on the wire as just for the documents as they're coming in.
Yeah. So you've changed a document, or you've inserted a document that appears on the change feed. You feed it into one of these real-time applications, platforms, and you do something with it. What you do with it is up to you.
Yeah.
Right. But you could do a whole load of stuff with
Well, we've got, I mean, Spark. You know, we've got PySpark in there. We can do sentiment analysis, any kind of textual analysis.
Yep.
You know, look at plagiarism in homework or something like that.
Yep.
Whatever it happens to be. Yeah, possibilities are endless.
But this is one of those features that I really don't know that's been called out.
Well, that's why you're here, aren't you?
Okay, that's the end of the slide deck. But what I wanted to do, as I said, we've got about 10 minutes left. What I wanted to do is, I said at the start that I'd give you some resources to get you going.
Yeah, that'd be really good. I think particularly we talked about that design of the right structure and working out, particularly we've got to have partitions, what we should use for our IDs on that.
So, first off is this. So this is a document DB emulator. Remember we spoke? And I want to do it on a plane, train, automobile, whatever.
So you're in a browser, but this is accessing something
Correct.
locally, yeah.
So if you So if you look down there in the bottom left-hand corner, you'll see like a database with the curly braces.
Yep,
Yep.
got it.
That is the emulator.
Ah, okay.
Right. So the emulator spins up, and then it exposes this Explorer. And in this Explorer, we can create a new collection. So I could go and I could create a new collection. Yeah. And then I could do a new document, right? And here's some documents that I've entered previously. And now what I can do is I can say, well, my application that I'm developing, I've been developing against this emulator whilst I'm on my plane. Let's go ahead and query. So select star from C is give me everything in the collection.
Yep.
Right? So, and it returns all of my documents. But maybe I want to filter that. So you can see here, yeah. So you can see here that I've got a company of Lotron. Right? Maybe I want to filter by that. So I could do where, let's change that to Lotron. Yeah. And I can order by this field, which is timestamp. And there you go. You'll see now I only have this document where the company is Lotron.
Yeah.
You okay?
Yeah.
So you'll see that I can do all of this. And you remember what I said about the language earlier on as well?
That looks very familiar.
It does look familiar.
I think I could write that.
Okay.
Just about, anyway.
If you have nested collections within your documents, this starts to get interesting.
But that's perhaps just like some of the more advanced SQL you'd write. You know, you're going to select into a group.
Correct. Correct. Once you start to go, and the Document DB team have released a series of crib sheets, posters where it takes you through, this is how you would filter for this. This is how you would do a where not exists. This is how you would do strings.
So sort of the SQL equivalent, and then showing you exactly what it looks like in this new work.
Correct.
Super duper. Yeah.
Correct. So if this is your, if SQL is your thing, then you can do that. So you can also use lambda expressions as well.
Right. Okay.
Yeah. So if that's your thing in C#, all good as well.
Right. And so I've seen there's a course on Microsoft Virtual Academy for this. I had a quick look at that to help me prepare properly for this session, because that's how we learn, isn't it?
Yep.
By teaching sometimes. And have you got any other sort of resources you'd recommend, Aaron?
So there's so one of your things earlier on to me was, how do I structure a NoSQL document given I can write whatever I want, right?
Yeah, that's the problem.
And we had that conversation. Well, the consultant's answer is it depends, right? But there's different ways to structure a NoSQL document with just, if you had an order with order lines, do you put all the order lines in with the order? Or do you have IDs that go and reference the separate order line documents? Yeah. Do you have the order lines with a reference to the order header? So a brilliant presentation that was given last year at SQL Bits was by Andrew Liu.
Oh, yes.
And it should be on our content. So we should have videoed that. It should be up there.
So it goes to SQL Bits website?
Yep, SQLbits.com website. Andrew Liu's presentation is very, very good.
Yeah, he is the guy.
I think he did a couple for us last year, but he definitely does how to model this.
Because obviously from what you're just saying, you could end up, I mean, a SQL guy like me would just naturally say, well, I'll just kind of recreate what I'm used to with your line on the header. Whereas a NoSQL guy might say, well, actually, that's ridiculous. I just want to write one document out. Correct. And I'll put my order lines and my order details all in one.
And that's where a lot of the speed comes, right? A lot of the speed from retrieving these things is that you don't need to do your 5 table joins.
Yes.
You just go and you say, I would like order 15, boom. It gives you details about whatever. It gives you all the order lines. It gives you who bought it, maybe. Yeah, and you do that in a one, right? And you retrieve it into an object, and then your application can go away and display whatever it wants to.
So do you have a formal, so, you know, if I do my data warehousing, I can go and buy a book by that nice Ralph Kimball, and there's Edgar Codsall stuff on normalization, and we spent weeks learning that stuff. Is there a sort of a definitive approach that the industry uses to kind of tease these problems out? You know, something maybe a bit abstracted from the technology, if you see what I mean, Alan, if I can.
So I've used Karen Lopez does, you know, Data Chick?
No, but I think I'll be looking afterwards.
She does very good modelling courses and posts. I've used Andrew Liu's stuff.
Yep.
I've used, there's some...
But there isn't an obvious, if you like, thought leadership.
I don't know of any ANSI SQL CODS rules about a NoSQL database, to be honest.
And how, obviously going back to your experiments example, you had, you put these million documents in and so on. Is that now in production, and how's that going?
Yep.
They're pretty happy with it?
They're insanely happy with it.
And was it a NoSQL solution beforehand, or was it a relational?
So it started out as an Elasticsearch POC.
Oh, okay.
And the ask from us was, if you were to do this in a Microsoft technology, how would you do it?
Right. Okay, and they just wanted to contrast and compare. And
so they wanted to contrast and compare, and we went through the classic, okay, seems to work, but what if this? What if this? What if this? And we got to a stage where all of their questions were answered. Speed was incredible for them. They hadn't had that kind of speed over that many documents before, and they were very, very happy with it.
And is that the sum of their documents is million, or have they got to put?
No, there's loads more. So this is just over 2 sets of experiments.
Right, and how many? So how much would that scale by?
So I think they're looking at 24 experiments.
Right, so it's
altogether. So they're going to have a fair amount of documents, right?
And did you have to use this partition thing for them?
Yep.
Yeah. So you're using all the belts and whistles, and you've enabled them to establish enough confidence to go live with this.
Correct. So my initial job was to give them confidence in the platform and show them that they can deliver what they need to.
Okay, fantastic.
Right. So couple of quick other things.
Yeah, sure. Sorry, Alan, I'm going on here, but it's such an interesting subject.
GitHub.
Oh, yeah.
GitHub is a fantastic place to go find document DB samples for a whole load of other stuff as well, right?
Yeah,
But go to...
Yep, and that's your Rimmer girl again.
That's Rimmer again. And you'll find loads of examples of using document DB. If you write in Python, all good. Node, all good.
Of course, yeah.
Right?
Yeah.
So whatever language you speak, chances are there's an SDK for you. The DocDB's blog, DocDB Teams blog. So you'll see here, this is where I think I stole that diagram from this morning, dear MongoDB users. There's our GitHub examples. But there's also this, which we were talking about this morning, right? So when partition collections initially came out, there was a relatively large gap between a single partition and where you could start with a partition collection. That's been reduced, so you can now start to use partition collections at a much lower price point.
And I guess that's important because you want to try out the partition concept without necessarily committing to it.
Of course you do. Of course you do.
Alan, this has been a revelation for me. I hope everyone else has enjoyed it as much as I have, and I'll certainly be having a long, hard look at Document DB. But for now, I'm going to let you go and have coffee.
Thank you.
And after the break, we're going to have a chat with that nice Mr. Hepworth about serverless.